So we're going to continue our study of solving equations. This new idea may be new to you or not new to you. It depends on where your teacher got to last year. So traditionally you would see this stuff, but this is my way of thinking about it. So go ahead and read the do now and then answer the question. Okay, I'm going to keep going. So if you missed this class or you're rewatching this lesson, you can pause now and read it and answer it. So now's your time. Pause, try it, and then replay the video, or stay with us. I'm going to read it right now and get going. Okay, so the do now. One side of the equation has the same number of coins as the other. Right? We talked about equations have equal signs, so we have this side has the same number of coins as this side. Each bag has the same number of coins in it. The question is, how many coins are in each bag if both sides have the same number of coins? So this side is equal to this side. And we don't know how many coins are in each bag, but we do know they have the same amount, right? So we have 1, 2, 3, 4 bags and 3 coins. And we have is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 coins. 12 coins, sorry, 12. Oh, no, 11 coins. Okay, so I would normally invite somebody up to come up and take a look. But because it's a recording, we'll just talk about it. So, how many coins in each bag? Well, I don't know, right? But I do know there's 3 here and 3 here. So if I just kind of take 3 coins off here and take these 3 coins off here, and then I know that these 4 bags must contain these 8 coins, because it has the same number in bags. So get rid of this 3, get rid of this 3. That means these 4 bags must have these 8 coins in it. All right, now the question is just how many coins are in each bag, right? Well, since we have 4 bags and 8 coins, that must mean that each bag must have 2 coins. Let's check it out. That goes with that, goes with this one, that goes with the last one, and that one goes with this one. Cool, yeah. 8 coins split between 4 bags. We now know that there are 2 coins in each bag. Awesome. And just by undoing and thinking about it. And I would have a student come up and explain it much better than I would, but that's where we're at. Okay. Normally I would take questions about homework, but because it's a recording, there's no questions to be asked, so hopefully it went well. If you're confused, just send me a message and I'll make a recording of going over the homework. But for now, we're going to keep going. So inside your notebooks, or maybe you've printed these handouts out, this is 1.5, Solving Equations with Bags and Coins, Part 1. So give yourself this heading if you're doing your notebook. And then you don't need to write down the question. Oh, I forgot a question mark option. All right, so we're going to think about solving equations with bags and coins. And we have an equation because we have an equal sign. We talked about that earlier. So here's the first one. Can you use the thinking we saw in the do now to figure out how many coins are in each of these bags? Oh, I have a bunch for you. So I imagine I gave this as a handout. So, I'm going to zoom this out. All right. So what I'd like you to do is we talk about how to do it in the do now. So with your partner, which we were doing in class, can you think of a way to find the number of coins in each example if both sides are equal? So I'll give you a minute. Go ahead and try to find the number of coins that we don't know in each set of problems. For time-wise, if you want to pause it now, do it. Just because I don't want the video to be too long, I'm going to keep going with the explanation. We'll go ahead and pause and try to find the number of coins in each bag for A, B, C, and D. I'm going to go over, starting at number 1. So, all right. So did anyone figure out how many coins are in each bag? And I ask you, how do you figure it out? Well, just like the do now, there's 4 bags and 2 coins, and that's equal to all these coins, right? And we don't know how many coins are in the bag, but we do know there's 2 here. If I get rid of these 2 on this side as well, then we know these 4 bags must contain all these coins, right? So how many coins are left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 coins left. So those 4 bags, who are the same amount, unknown coins, must split the 16 evenly. So it's 1 bag, 2 bags, 3 bag, 4 bag. So 4 coins per bag. Sweet. All right. Now we got B. Same idea, just a different problem. We have 3 bags and 5 coins equals this one. So again, maybe we could just cancel this out. 5 from here and 5 from here, and that would tell you that these 3 bags contain the rest of these coins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, 3 bags containing 15 coins altogether, so it must be 15 divided by 3. We have 5 coins per bag. Ooh, all right, number C. Hopefully it went well. And this is our first one that we're seeing that we actually have bags and coins on both sides. Okay? So normally I would invite someone out, like, how did you approach figuring out the number of coins in each bag if the same number of coins have to be in total altogether? Well, what I often see is students say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So they can start getting rid of bags and coins, right? So we can get rid of 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. So if 2 bags and 1 coin equals 3 bags. And then someone often says, well, the bags have the same amount, just like the coins did. So why don't this has 2, this has 2. So why don't we just get rid of these 2 bags and these 2 bags? And that tells us that 1 bag has 1 coin. And we can check. 1, 2, 10 is 12, 9, 10, 11, 12. Yep. 1 coin per bag. Sweet. Okay. So we can approach getting rid of bags just like we did getting rid of coins, which is great. All right, we'll jump to the next one. Okay, so did anyone figure out D? And D's a little weird on purpose. I gave it as a challenge. Did anyone figure out how many coins are in this bag? If we have 4 bags and 6 coins equals 2 bags, how many coins in each bag? Well, what we find is this one may not have an answer. And we'll talk about why later. But just think in mind that we actually can't get a number of coins unless we think a little differently about it. So hang on to number D. We're going to talk about that tomorrow. Okay. So this is part 2. And at that point, someone might have said we can write equations to solve this. And yeah, we can write equations to represent bags and coins. Finding the unknown number of coins is just kind of like solving equations for an unknown variable, right? We can represent problems below with an equation with numbers and variables instead of thinking about bags and coins. Since we have 4 bags and 2 coins. And these bags, we don't technically know what's in them. We can say that we have 4 bags with unknown amount of coins plus 2 coins equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18 coins, right? So this is a way to represent the exact same thing. 4 bags of unknown amount plus 2 coins is 18. Right. And we've been practicing solving this, but let's just think, right? Like we were getting rid of 2 coins. We were getting rid of 2 coins, right? And that's like taking away 2 from both sides of an equation, right? And then we were splitting the 16 coins left with the 4 bags, and that's division, right? So we take our 4 bags and split it evenly with the 16, and there we go. They must have 4 coins per bag, or that x equals 4. Okay, so what I'd like you to do now is try one yourself. Instead of thinking bags and coins, let's try to write an equation. So if you have 1, 2, 3 bags and 1, 2, 3, 4, 5, 6 coins, and that equals this many coins, can you write an equation and solve it? And this is where I would have you turn to your partner, write an equation, and talk to each other about solving it. You can continue to watch it or pause it. I'm going to keep going. Well, we have 3 bags where we don't know how many coins are in them. Plus, we have 6 coins on this side. And we're saying that's equal to 1, 2, 3, 4, 5, 6. 6 times 2 is 12 coins. Right? So we can solve it and just think of it like taking away the coins, right? What are we doing? And then we're going to split the 6 coins evenly among 3 bags, and that's division. So we got that x equals 2. We solved the equation, or figured out how many coins are in each bag. Okay. I wonder if I got rid of one by accident. All right, so this is a longer lesson, but we're almost done. Okay, so this is our last example here. We got bags and coins. But now we have bags and coins and bags on both sides. So does anyone think they can write the equation to represent this? And someone might say, well, we have 6 bags of unknown amount with the coins. 1, 2, 3, 4, 5. 15 coins on this side. And that equals 19 coins plus 4 bags on this side. Right? Okay. We can still solve it if we want to think about them like bags and coins. Oops, what that is B. Or we can just think of coins. How can we solve this with coins and bags? Well, if there's 15 coins here, we can get rid of the 15 from this side, and that's like taking away 15 from both sides. Right? Coins take away from coins. So we get 6x equals 4 plus 4x. And then we can get rid of 4 bags on this side and 4 bags on this side. So take away 4x, take away 4x. And we get 2 bags equals 4 coins. And now we can see that x equals 4 divided by 2, which is 2. Sweet. So you can approach solving equations while thinking of like bags and coins. Bags away from bags, coins away from coins. So, big question is, how is finding the number of coins in a bag similar to solving an equation for a variable? Well, I would say it's basically the same thing, right? You're undoing what you can from both sides taking coins, or numbers from numbers, variables from each side, or bags from each side. And we'll find our way down to our answer. Pretty cool, right? Okay, so we're going to move away from bags and coins, but you can think about this type of problem the exact same way, right? So what I'd like you to do is, this is our classwork, kind of a long lesson. So either write this down in your notebook and show your steps, or you printed it out, but there's not a lot of space. Okay. And you're going to solve this for x. And then the homework is below as well. So I want to show you what I'm looking for. We'll just do number 1, and then you're off to the races. So if you're adding this to your notebook, here you go. You have 7x equals 5 plus 2x, 5 plus 5x. And we're going to solve this one. All right. If we think of x as like bags, we have 7 bags equals 5 coins plus 5 bags. Does anyone have a thought on what we could do to both sides to solve this? I'd follow up. Well, there's coins on this side. There ain't coins on this side? No. But we have bags on this side. Bags on this side. All right, so what do you think? Take away 5x from both sides? That's amazing. That's right. We can take 5 bags from this side and 5 bags from this side, and we're left with 2x equals 5. And now we need to split 5 evenly with 2. So we'll divide both sides by 2. And you get that x equals 5 over 2. And this is a good example to know that we can't, this wouldn't be a problem for bags and coins, because you'd have to have a half a bag, or half coins and things like that, which doesn't make sense. But you can. So with your partner, I want you to go ahead and keep going. Start solving these. Think of bags and coins, right? Bags away from bags, coins away from coins, and finding out what x is. Or x's with x's, numbers with numbers, integers with integers. Okay? And when you're done with 1 through 8, the homework is the same thing. I want you to solve each equation, doing things to both sides. All right. I'll answer any questions people have in class, but that's the end of our video.